Hello there and welcome to part 2 of this review of Shikun UV-25, also known as Quansheng UV-R50. And this video we're going to focus more on the actual measurements of this great radio. And for this, as you can see, I've prepared some equipment here to perform this task, or to help me perform this task with as much accuracy as possible. Oops, sorry about this. Okay, so we can start basically by measuring the frequency stability. This is measured, or I'll measure this using my no-elec SDR dongle, which is connected to my 2530p HP, as you can see, and it's running SDR sharp, and it's currently tuned to 432 megahertz, 432.7 megahertz, as well as those radios. So as this SDR dongle features very high precision TXCO, we can basically tell how precise are those radios in terms of frequency. So basically, if I key this by pressing the PTT button, I should see some sort of change in the waveform. And as you can see, we are a little bit off, but still within the limits. If we check that, it should be, yeah, so we're basically 140 Hertz off, which is great. It's actually within the limits of 0.5 parts per million. So actually this thing might be even less precise than this Shikun radio. And for comparison, we got Baofeng UV-B5 here, which tend to be a little bit more off. If we key this, yeah, it's more to the left side, and there's 300 Hertz difference. Still not that much, it will work perfectly fine, but you can see there's some sort of jitter. So it's not like 100% stable, and it tends to move around as the heat on the TXCO rises. With this, we can actually check the frequency deviation of both the narrow and wide mode of this Shikun, and as well this Baofeng, and then compare them how well they perform. To do this, we'll basically again use our software here, tune the frequency to 432.7, and extend this filter to the way it should be. We are talking about F11E modulation, which is frequency modulation, which is 11 kilohertz, which should be 11 kilohertz wide. And the way we're going to do this is very simple. We're just going to key the radio and blow into the microphone like this. So you can see the deviation is exactly what the channel permits. It's basically not undermodulated or overmodulated. It's exactly how it should be. The same thing should be when I'll set this radio to wide modulation. Currently it's set to narrow, as you can see. So I changed this to wide, and now it should be 16 kilohertz based on the specification. So we'll set the bandwidth to 16 kilohertz, and again blow to the microphone. And again, it's, as you can see, very close to the limit, and actually this is the way it's properly done. It's not actually exceeding this limit by any means. This is the way the modulation characteristics should be done. Okay, for comparison, let's look at this Baofeng. We'll start by setting the power level to optimum, and let's check out the narrow width, which should be 11 kilohertz. Let me just take this filter down to 11K. Here it is. So if I blow to the microphone like this, this is very scientific, by the way, we are within the limits, more or less. Let's check again. Yes, we are basically not exceeding the limits by much. But we can see there's some sort of filtering going on, because the amplitude is shifted to towards the sides. So if we again check one after another, this is Shikun. You can see that the quality is, or the modulation is more even throughout the spectrum. And if I do the same with Baofeng UV-5, the spectrum looks different. Also, this one is set to wide, of course, but you can see there's some sort of audio filtering going on. So the way we do this with higher width 16K, you used mainly here in Europe on direct channels on 70 centimeters amateur band, and it looks like this. And as you can see, we are a little bit over the limit here. Not that much on the right side, but you can basically, let me do this again. You can see there is some sort of audio filtering going on, and this kind of noise varies a little bit. This, of course, doesn't tell us much, but overall, this Baofeng modulates a little bit worse than this Quansheng. I can even do this right once again. I can set this to narrow, and you can see this is the way it should look like. Now let's look at the audio frequency bandwidth of this radio. For this purpose, we should tune our SDR sharp to the frequency of our choice, and deselect here filter audio and select output to cable input. In this case, I'm using VB audio cable and fitting this audio here to gold wave. So the way we test this is just by keying the radio and again blowing into the microphone and checking out the frequency it cuts off at. So if I key the transmitter like this and blow it into the microphone, blow into the microphone like this, you can see that the audio cuts off at 3 kHz, which is basically the way it should be. The way it should be, because there's a EN norm which specify that the audio in frequency modulated signal should be basically, or on ham bands or on the public bands should be basically 300 to 3000 Hertz. So this is the way it's according to the norm. In this way, it's according to the specification. If we check out the Baofeng, we can compare. We can see that the filtering is a little more gentler. The cutoff frequency is not that harsh as in this case. We can check side by side. In this example, we can see that the filter is much sharper. It cuts off much sooner than here on Baofeng. And there's even some audio processing going on the Baofeng side. That would conclude our test on this machine using this SDR receiver. And now we can basically move to measuring the power output of this Shikun. For this purpose, I have this power meter here, RF power meter, which is supposed to measure from minus 75 dBm to plus 16 dBm. But of course, this Shikun puts out over 30 dBm, so we need to use attenuator. And I have a couple of these. These are variable attenuators. We'll use this in our sensitivity testing. And this fixed attenuator, actually this one was manufactured in Florida, Port Salerno, Florida. So the way we do this is by unscrewing the aerial, screwing in this fixed attenuator. I prefer to do this on this side rather on here, because this way basically eliminates all sorts of inductions that might happen during these measurements. So we'll of course need all the appropriate adapters, like this one, And to keep the cable as short as possible to avoid any huge margin for error, or to eliminate as much error as possible, we can keep this frequency to 432,700, and then we can power out on our RF power meter, and it's already reading some noise, which I prefer to keep it stabilized for a bit. Okay, now it's settled to 74.7. So since we added 20 decibels of attenuation, I'm just going to, let me make this easier for you. I'll increase this attenuation factor by 20 dB plus 4 decibels because there was some error. So I calibrated it on a scope and found out that it measures 4 decibels off. So right now, if I key the radio, we should get our power level as close to real life as possible. 29.8 decibels above milliwatt. That's basically exactly 1 watt. And right now we are right now we have the low power mode activated, and if I increase the power, we should get basically a 36. That would mean almost 5 watts. Or yeah, exactly, we're getting 36.8, 36.9. So that means this transmitter, or this TX, is exactly up to specs as it should be. Okay, and now we're going to measure sensitivity of the receiver in this Shikun SQ-UV-25, also known as R50. And the way we're going to do this is by using both of these variable attenuators. As you can see here, it's a little bit of a mess, but it'll get the job done. I've set this one to 60 dB. I've set this one to 0 for now. And as a signal source, we're going to use this Quansheng UV-5R, which I have set to minus 48.1 decibels in terms of carrier wave amplitude. So this thing is currently putting out minus 48 decibels above milliwatt. That's approximately 22 nanowatts of power. We're feeding this through 20 dB pad here to this variable attenuator, which is currently set to 0. And then we're feeding it to this variable attenuator, which is set to 60. So at this point we should be getting around minus 68, minus 128 decibels with this set to 0. So to this Shikun, we're introducing minus to prevent any sort of interference along the cable, which can happen because there might be some sort of RF field induced in the cable, which would skew out the result. I'm going to place these far away and set this squelch level to 0 and introduce our minus 128 decibels worth of signal into this Shikun. Okay, now the noise gate is active and I'm keying the transmitter now. Okay, I'm going closer because this omnidirectional mic might be able to pick it up. So as you can hear, there's most definitely some difference going on even at this level of signal. So I'm going to go a little bit further and check if we can actually hear it even lower. So as of now it's set to 128, 129. It's almost not there anymore. 130, 131, 132, keying, not keying. I can barely notice the difference. 133, and there's no difference. basically. So let's increase it to 135. No. Okay, 135 we're getting some sort of noise change. If I stay right here. At 136, not anymore. Okay, let's raise it to 128. And let's raise the stakes a little bit higher. And now we're looking for a level that's actually 100% copy. So I'm decreasing the value from 60 to 50 now. So we should be getting 118, minus 118. And it's 100% copy. Or let me put the microphone there, just in case. Yes, so minus 118 decibels is 100% copy. Okay, let's take this level a little bit lower. Minus 119, minus 120, minus 121, minus 122, minus 123. There's a little bit of static, but it's picking up the signals quite well. Okay, let's go further. 123, 120, sorry, 33, sorry, 123, 124, 125, 126. This should still be 100% copy at 126 decibels, minus 126 decibels. I'm not sure you can copy this. Okay, let me raise it to 125. 124. This is definitely 100% copy. Yeah, this is definitely 100% copy. And finally, we have come to the last part of this measurement video, and this is to test the audio RX, or to give you the subjective idea of how the audio is coming from this speaker. So let's turn it up once again. Turn off the squelch, and I'm actually going to place my lapel microphone right next to there and open the squelch so you can hear for yourself how the noise sounds. So this is the way the noise sounds. I can give you then how it even looks like. I'll be right now you can see the picture of how the audio looks like right from this audio jack, 2.5 millimeter. The first one is the first speaker. So this is how it looks like from the speaker itself, and this is how it looks like straight from the connector. And finally, we can hear for ourselves. So I'm turning on this UV-R50. Sorry, that was a grave mistake. And I'm going to leave my lapel microphone right here, inserted on the speaker, and I'm going to move away from the camera. So this is basically how the audio should sound like through this speaker, and this should also test out the audio quality and how the audio goes through this Quansheng UV-R50. Okay, this concludes our test part of this Quansheng UV-R50 video. Stay tuned for the next one. Part 3 is going to be mods or modifications to this handheld We'll look at how we can set the frequency, correct the frequency even though it's already corrected, and we'll be looking at some power mods, how to take the power down or up, whatever you prefer. So stay tuned for the next one, and I'll catch you later.